Hoo-hoo! It's a great day to be in geometry. I'm Miss Legg-Battles, and I'm here today to talk to you about finding angle measures using the inverse trigonometric functions. That's right, I'm here putting the fun in functions. Previously, we talked about that a trig function, like sine, of an angle measure that we might describe as A is equal to a ratio, like A over C. And we used this when we were looking for either A or C, if we were looking for a side of a right triangle. But today, we're going to be looking for the angle measures. So we will use inverse trigonometric functions because an inverse trigonometric function of a ratio is equal to an angle measure. So if you know the ratio and you're looking for the angle measure, we're always going to use the inverse trig functions. So if I take my sine of A equals A over C and I rewrite it where it's solved for the angle measure, it would be the inverse sine of A over C is equal to A. Here's my ratio, having the inverse trig function of the ratio, and capital A stands for the angle measure. Now, in the problems that I've chosen to work with you today, we have angle measure x, and we're given that this side is 5, which with respect to x would be the opposite side, and 14, of course, is the length of the hypotenuse. So using my trig function that has opposite and hypotenuse in it, that would be sine. Sine of my angle measure x is equal to opposite, which is 5, over hypotenuse 14. So this is just like what we would set up before. The difference is we know both the 5 and the 14, and we're looking for the angle measure. It's right here. X represents the angle measure that we're looking for. So remember, we're going to use inverse trig functions to find the angle measure because the inverse trig function, illustrated this way, of the ratio, which is 5 over 14, is equal to the angle measure, which in my problem is x. So we just need to use our calculators. Now, if you'll look at your calculator, inverse sine is usually the second function key. So look above sine, you'll use that second function, so hit that blue second function key, and then sine, that gives you inverse sine of 5 divided by 14. And we're going to round that value to the nearest degree. So in this case, that's approximately 21 degrees. Now, another way that students sometimes look at this is they say when we start with this initial equation, that is sine of x is 5 over 14, what if we just take the inverse sine of both sides? So I start with sine of x equals 5 over 14, but I'm going to take the inverse sine of both sides. Now, the inverse sine of the sine, see, those are inverse operations, so that goes away and just leaves you with the x. And x would be equal to, I can do better than that, x is equal to inverse sine of 5 over 14. Well, that's exactly what I have over here. Inverse sine of 5 over 14. It's just a different way of looking at it. I'm still going to find that angle measure, put it in my calculator. It's about 21 degrees. So I like to look at it this way, that remember, an inverse trig function of a ratio is equal to an angle measure, but some people like to look at it this way, that we're taking the inverse sine of both sides. Let's move on to the next example. In the next example, I'm looking for this angle x. 8 is the opposite side, and 5 is the length here of the adjacent side. So which trig function that we studied involves opposite and adjacent? That would be, of course, tangent. So tangent of x is equal to the length of the opposite side, which is 8, over the length of the adjacent side, which is 5. So let's put this in our calculators. The inverse tangent of 8 over 5, because that's going to be equal to my angle measure x. So the inverse tangent of 8 over 5, and then I'm going to round to the nearest degree, and that gives me approximately 58 degrees. Are you checking that on your calculator? Approximately 58 degrees. I hope these examples help you to find angle measures using our inverse trigonometric functions. It's a great day to be in geometry. You have a good day.